In degree of vertex V3 is 3. So depends on the number of edges which is reaching to. Yes, I will explain once again here. The number of vertex is, this is most important here. How we are going to count the in degree? Just I want to count the V3 in degree. In this figure, V3 in degree. So just count from remaining vertices. From remaining vertices, how many roots or how many edges are reaching to V3? That total number will give the in degree of V3. Okay. So in this figure, we have one root from V1 to V3. That is edge E5. We have one root from V2 to V3. That is we have edge E2. And from V2 to V3 also we have one edge, that is E3. So totally 3 vertices are reaching to V3. So it comes under the in degree. So the total in degree of V3 is 3. So what is the definition of in degree? Just count how many vertices are reaching so and so particular vertex. That vertex in degree will goes to total number of reaching the vertex V. So in this figure, V3 having 3 edges. One is E5, one is E2, one is E3. Just now I showed in this figure. Okay, once again I will explain this here. So in this V3 having in this figure, V3 having 3 edges reaching V3. V1 to V3 is one edge E5, V2 to V3 having one edge E2, V4 to V3 also having edge E3. So totally 3 vertices are reaching to V1. So the total in degree of this V3 is 3. Is it clear? Similarly, I want to count the in degree of V4. In degree of V4. In degree of V4 means, see, just count how many vertices, remaining vertices are reaching V4. So V1 to V4 we have one edge here, arrow mark, this arrow mark. V1 to V4 we are reaching means this is one in degree. And remaining, this is living. Don't count this. It will go to out degree. Okay. We have only one edge E4, which is moving from V1 to V4. So the in degree of V4 is 1 only. Okay, this is about in degree of individual vertices V1, V2, V3, V4. Now same we have to count the out degree of V1, out degree of V2, out degree of V3, out degree of V4. Okay, just we need to count same this but out degrees. Out degrees means as I already explained. What is the meaning of out degree? Yes, out degree. What is the meaning of out degree? Just count how many edges which are leaving that particular vertex. So if I want to count the out degree of V1, out degree of V1 means just see how many edges which are leaving the V1. The total number is known as out degree of that particular vertex V1. So in degree means reaching to the particular vertex. Out degree means leaving the particular vertex. Okay, whether it may be V1 or V2 or whatever it may be. In this figure, let me count one by one. What is in degree? So just count what is in degree of V1, what is in degree of V2. Similarly, what is in degree of V3, in degree of V4. So count one by one. So I will show it in the figure here. In this here, I want to count out degree, yes, out degrees of V1, out degree of V1 here. Yes, what is the out degree? How many edges which are leaving the V1? The total indicates out degree. So V1 it is living E1 here. E1 is living degree. V1 to V2. So it is living in this direction. It is living. If direction is like this, it is reaching. Reaching comes under the in degree. Living comes under the out degree. So here I am going to count the out degrees. Out degrees means how many edges are living, or how many roots we have another vertices. So here v1 to v2 we have one living edge. So this is 1 plus. Next v1 to v3 e5 is living, edge e5 is living. This is 1 plus. Next v1 to v4, this is e4, this is 1 plus. And we have one loop. Whenever loop is given, I already told, loops indicates it having two edges. Two edges. Now the degree of that v1 will be 2. We have to count twice. One should be clockwise, one should be anti-clockwise. Okay. So clockwise will goes to one in degree, anti-clockwise will come under the out degree. Okay. So in v1 we have one out degree because it has a loop. v1 to v1 itself. So total how many we have? 1, 2, 3, 4. This is v1 to v1 e1, v1 to v3 e5, v1 to v4 e4, v1 to v1 itself, that is e6. So totally we have 4 roots which are living from v1 to other vertices. So this is out degree of v1 is 4. Similarly, tell me what is out degree of v2. Out degree of v2 means how many edges which are living. Yes, e7, v2 to v1, this is living, and this is also living here, v2 to v3. So v2 to v3, e2 also living, e7 also living. So the degree of v2 will become 2. So out degree of v2 will become 1 plus 1. It is 2. What is that one? First, v2 to v1. This is e7 degree, and v2 to v3. This is e2 degree. So totally we have 2. Okay. Similarly, the out degree of v3. Just count how many we have. How many edges which is living. So e2 is reaching, e5 is also reaching, e3 also reaching. No edge is living. Is it clear? In these figures here, no one vertex or no one edge is living from v3 to other vertices. So there is no out degree for this. Is it clear? Because all are reaching, not living. Okay. Therefore, the out degree of v3 is 0. Right. Similarly, the out degree of v4. Out degree of v4 is how many vertices we have living from v4 to remaining v4 to v1. It is not living, it is reaching. So it will come under the in degree. v4 to v3 is this is one out degrees here. Only we have one. So this is one. Right? This is about in degree, out degree. And I want to count the total degree or total degree of vertex, either it may be v1 or v2 or v3. So total sum of in degree plus out degree, sum of in degree plus out degree will goes to total degree of that particular vertex. Already we discussed it. The total degree of vertex is here, this here. It is already in undirected graph. We discussed all these things. Just check out whether it is correct or not. What is total degree of v1? 6. So just count here. In degree is 2, out degree is 4. So total degree of is 6. v1 is 6. Similarly, total degree of v2 is what is v2 here? 3. So in degree 1, out degree 2. So it is 3. Similarly, total degree of v3 is, check out, it is 3. Here also we'll get the 3's here. In degree 3, out degree 0. So again it is 0 plus 3, 3. Yes, it is tallying. Next, v4 total degree. v4 total degree we have here 2. Among the two, one will be in degree, one will be out degree. So totally it is 2. So it is having satisfying this condition. Okay. So the total, what is formula? The total degree of any vertex v equal to in degree of v plus out degree of v. This is the formula. So total degree of. So the in degree out degree. Yes, once again I'm explaining here. The in degree out degree must be exist for directed graphs only, whereas only undirected it indicates total degree. We don't know how many in degrees, how many out degrees, but I want to count the in degrees, out degrees means definitely it should be having as directed graph only. Is it clear? This is about degree of any vertex. Okay. So based on this, we can count how many in degrees and how many out degrees for a particular uh, a particular. We can count the number of here. Okay, based on that directions, how many directions are leaving the vertex, that is indicates the out degree. How many directions which are reaching the particular vertex, that is in degree. So total in degree plus total number of in degree plus total number of out degree will give the total degree of that particular vertex. Okay, based on this we can count the degree of vertex. Okay, next we will discuss the next topic. Yes, I will share the screen. One minute. See here. Already we discussed all these topics in previous class. Next, I'll going to start the here all these about in degrees, out degrees. Matrix representation and graphs. 1 minute. I'll show it. 1 minute. I'll explain about K1, K2, Kn graphs. See, yes, this is definition of regular graph. Regular graphs and complete and regular graphs here. Let me discuss. This is also one of the most important topics. What is coming to the what is the complete graph? A simple graph G is said to be complete if every vertex in G is connected to every other vertices. Means complete graph means in that graph, each and every vertex having the root from other from that vertex to remaining vertices, it having root. So every vertex is connected with other vertices. Then we can say that is known as complete graph. Okay. So a simple graph G is said to be complete if every vertex G is connected to every other vertex in G. There exists an edge between every pair of vertex in G. The complete graph with n vertices is denoted with Kn. So Kn indicates complete graph. Kn means it having n edges, sorry, n vertices. If K2 means it having two vertex. A complete graph is sometimes referred to as an universal graph or a click. The following are the few examples for complete graphs. See here. In this here, first example, this is K1. It is isolated graph because we have only one edge. From this, we don't have any root map to other edges. Actually, there is no any vertices. It having only one single vertex here, and it does not having any root map to other vertices. So it is known as isolated vertex. Next, line segment. Line segment means it is also having two vertices AB, and I'm connecting with one connecting with one line. So it known as line segment as well as it is complete graph because we have the root map from A to vertex A to B as well as vertex B to A. Okay, vice versa. So this is known as complete graph with two vertices. Is it clear? This is complete graph with two vertices. And let us take complete graph with three vertices. Yes, this is triangle A, B, C. Totally we have three vertices A, B, C, and each and every vertices having the root from one vertex to remaining all vertices. If you take one example A from A vertex to remaining B and C, we have root maps here. A to C we have, A to B also we have. So this is complete graph. Let us take complete graph with four vertices. This is A, B, C, D. A, B, C, D means here. I will explain this. Here we have so in this here, complete graph means a graph from a graph. See how many vertices we have in that particular graph. If it is only one vertex is there, that is known as isolated vertex because we have only one vertex. From that vertex to remaining vertex, there is no any root map. Actually, there is no any vertices other than V1. So simply we have only V1, that is isolated. If it is two vertices are there. If two vertices are there, then the graph will become here. So Kn, the Kn indicates it is complete graph. It is notation of complete graph. Complete graph with n vertices. N vertices. Okay. If it is K1 is there, means n equal to here 1, means it is a complete graph with one vertex only. It indicates with dot like this only. Indicates this is A. So or this is some V, whatever it may be. V or A, whatever it may be. So in this here, in this we have only one dot. So there is no another vertices to connect from this A to other one. So this is called a complete graph with vertex 1 only, or with n vertex means n equal to 1 only, or simply we can call it is isolated graph. Similarly, if n equal to 2, let us check how it will be. The complete graph will be here n equal to 2 means K2, and I am going to take two vertices V1, V2. Okay, I am connecting with these two. So we have two vertices V1 and V2, and we have connectivity from V1 to V2 as well as V2 to V1. Means this is complete graph with two. It is complete graph. And sometimes we can call it as a line segment. Line segment. Okay. So this is the example of complete graph with vertex 2. Next. Let us take n equal to 3. I'm taking complete graph with 3 vertices. So I'll take V1 here, V2 here, V3 here. So join all this with one line with lines. So this is complete graph with 3 vertices. This is called triangle. Okay, or a complete graph with 3 vertices, because here V1, V2 with 3 vertices we have, but each and every individual vertices we having the root map to remaining vertices. Means all vertices connected with remaining vertices. Each and every vertex is connected with remaining vertices. Similarly, n equal to 4, let us take K4 will become K4. I am taking V1 here, V2 here, V3 here, and V4 here. Is connect with this all vertices. Is it complete graph? It is not a complete graph. Why? Because V1 to V2 is there, V1 to V4 is there, but V1 to V3 there is no connectivity. So connect this. Still it is not a complete graph. Why? Because V2 to V1 is there, V2 to V3 is there, but V2 to V4 is not connected. So take one direction like this. Okay, now it will become complete graph. It is a complete graph. Yes, it is a complete graph with 4 vertices. Okay, it is complete graph with 4 vertices. Okay, so what is the meaning of this? Every vertex is connected with remaining all vertices in that entire graph. Okay, that is connected graph. Similarly, you can take with 4 or with 5 like this. N equal to 5, K5. It is not with K5. Just first take the 1, 2, 3, 4, and 5. I'm connecting all this like this. Okay, this is V1, V2, V3, V4, V5. Now it is not a complete graph. Why? Because V1 to V3 there is no root. V1 to V4 is also there is no root. So connect like this. Still V2 to V4 is not there. V2 to V5 is not there. So connect this. Still V3 to V5 is not there. So connect this like this. Now it will become complete graph. Is it clear? It is complete graph because each and every vertex having the root map to remaining all vertices, or simply each and every vertex is connected with remaining all vertices. Similarly, n equal to 6, K6, how the graph will become? See here, 1, 2, 3, 4, 5, 6. I'm taking this is V1, V2, V3, V4, V5, V6. Now we have to connect from V1 to remaining all. First, take the figure like this. Is it clear? Are you able to following me? No, it is not complete graph because V1 to V3 connect one root. V1 to V4, V1 to V5. Similarly, next V2 to V2 to V1, V3 we have, V2 to V4, connect this. V2 to V5, connect this. V2 to V6, connect this. Similarly, V3 to V2 is there, V1 is there, V4 is there, but there is no V5. connect this, and there is no V6, connect this. Next, V42, V42, V3 is there, V2 is there, V5 is there, V1 is there, but V6 is not there. So connect this. Next, V52, yes, every vertex is connected with remaining all vertices. So this is complete graph. Complete graph with 6 vertices. So what I'm saying, the each and every vertex is connected with remaining all vertices. Then that is known as complete graph. Okay. X. Yes. Are you following me? So complete graph means in that given graph, each and every vertex must be connected with remaining all vertices. Then that is comes under the complete graph. I shown a few examples for n equal to 1, n equal to 2, 3, 4, 5 up to 6 and so on. Okay. And a complete graph is denoted with Kn. Kn means complete graph with n vertices. If K1 means complete graph with one vertex only. If n equal to only 1, that is known as isolated graph. Okay. If n equal to 2, that is 2 vertices connected with v1 to v2, v2 to v1, vice versa. Then that is known as complete graph with a degree, with a vertex 2. And that is also known as line segment. And complete graph with that is triangle and so on. Okay. And next topic. Let's the next one. See here. Next, I'll share the notes. See here. 1 minute, I will share the notes. These are few examples for complete graph. Next definition. Yes, these are the as in our textbook in page number 35. We have all these examples. Just go through it. Next, complete graph. Next, coming to the regular graph. Okay, regular graph. Yes, these are the examples for K5, K6 here. Okay. Next, see here. One important note based on complete graph. In a complete graph, G of n vertices, that is Kn, the total number of edges is given by, this is the formula. Please remember this. For objective type questions, this is the most important topic. Whenever n vertices are there, in that we have total number of edges will be n into n minus 1 by 2. Okay, this is formula. A graph, it having n vertices and it is complete graph, then it having the number of edges will be n into n minus 1 by 2. Okay, let me check out whether it is correct or not. Okay, I will show with a number of edges in complete graph is, what is formula? N into n minus 1 by 2. Just check out whether it is correct or not. Just I will explain the one example here. This is the formula. This is the most important formula for object type questions. In your final exam, maybe these type of questions will ask in your final exam for short answer purpose. So just they will give the, yes, this is the graph, complete graph. Is it complete graph? Yes. Now is asked how many edges are there in this graph. So what is n here? 3. So n equal to 3 means the formula will become 3 into 3 minus 1 by 2. So 3 into 2 by 2. So totally we have 3 edges. Just check out whether it is correct or not. Yes, we are having, this is V1 to V2 one edge, V2 to V3 one edge, V1 to, this is 2, this is 3. Okay, V1 to V2 I am indicating E1. Okay, V2 to V3 I am indicating E2. V1 to V3 I am indicating E3. Total we have 3 edges. Okay, let me count this. So how many edges we have? V1 to V2. This is E1, E2, E3, E4, E5, and this is E6. Okay, total 6 edges. What is n here? N equal to 4. Just substitute in this formula. What is formula? N equal to number of edges, E equal to n into n minus 1 by 2. So 4 into 4 minus 1 by 2. So 2, 2, 2. So 2 into 3, 6 edges. Is it correct? 6 edges. Like this, in this here, n equal to what is 6? N equal to 6. So number of edges will become 6 into 6 minus 1 by 2. So 2, 2, 3. 3 into 5. So 15 edges will become, will have in this entire figure. Just we want to give the numbers E1, E2, E3, E4, E5, E6. This is the suitable formula for complete graph only. Okay. So, of course, it is complete graph. How many edges we have here? N equal to 6 means total 15 edges will get. Just see E1, E2, E3, E4, E5, E6. Next, this is E7, E8, E9. Just I am giving the numbers from V1 to other out degrees. Next, V2, V2 to E9. This is E10. This is E11. This is E12. Next, V3. Already E7 is given. E3 to V6. E12 means E13. E13, E14. Next, V4 to already E8 is given, and E14, this is E15. Okay, and this is all given. Next, V5, V5 to S15, yes, total completed. It is given complete 15. Okay, these are the total number of edges. Whenever it is a, yes, whenever it is a complete graph is given, then the total number of edges will be counted by this formula, n into n minus 1 by 2. Okay. Next, coming to the regular degree. This is about complete degree, and in complete degree, how we are going to count the number of edges. Okay. Next. Okay, I will finish within 2 minutes. I will finish. Okay, just I will finish within 2 minutes. Just I will share the notes. Just I will explain the only one